target today is to be able to dilate coordinates that are from dilation centered at the origin. So the first question we're going to look at is going to be like kind of a do now for us. It says triangle ABC has vertices A 6 6, B 9 0, and C 3 -3. State and label the coordinates of A prime, B prime, C prime, the image of this triangle ABC after a dilation of 1/3. If you can't see that, it says 1/3. And this is just straight from yesterday's lesson. It would have been put in like a recap for us. So all you have to do is multiply this 1/3 by all of these points, right? So A prime will be 6 times 1/3, comma, 6 times 1/3, right? B prime would be 9 times 1/3, comma, 0 times 1/3. And then C prime would be 3 times 1/3 and -3 times 1/3. Okay, and then that would give us points. 6 times 1/3 is really like 6 divided by 3, right? 6 times 1/3 gives you 2. 6 times 1/3 again gives you 2, so that point is 2, 2 for A prime. Then we've got 9 times 1/3 is really 3. And 0 times anything is 0, so that's an easy one for B prime. And then finally C, well, 1/3 of 3 is just 1, and that goes for it twice, but this one's negative, so this is a -1, and that's our C prime. So that's the coordinates of A prime, B prime, C prime, the triangle that ABC was dilated 1/3. The next question we're going to look at is on the graph, and it talks about parallel lines here. So triangle QRS is graphed on the set of axes below. On the same set of axes, graph and label Q prime, R prime, S prime, the image of QRS after a dilation with a scale factor of 3/2 centered at the origin. Use the slopes to explain, right? Explain why Q prime, R prime is parallel to QR. This actually isn't as difficult as it seems because we know a lot of stuff about parallel lines in the coordinate plane. And the dilation is not too difficult either because we know just from the do now, all you have to do is multiply the points. So once you find out the points, like Q is -1, -2, 1, 2, right? So Q is -2, 2. R is 1, 2, 0. R is 2, 0. And S we don't really need, but we can do it. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4, 6 for S. And these guys are just going to get times by our scale factor, 3/2, right? So we're going to multiply this point by 3/2, this point by 3/2, and this point by 3/2. Okay, so when we multiply our Q by 3/2, we end up with -2 times 3/2. And if you want to do this in the calculator, you definitely can. But -2 times 3/2, those 2's cancel out there, and you get a -3 on top. And I can just show you guys in the calculator if you'd rather do that. This one here, turn this light off. It'll be a little bit better. Okay. This one here, we got, again, 2 times fraction, and then we know it's 3/2. That's what our scale factor is. And we get 3. So, again, you can see that it's 3, and that's our Q prime. Our R, we got to do the same thing. We know 3/2 times 2, we just did it, is 3. Anything times 0 is 0, and that's our R prime. They're only asking for that. If you want, you could do S. I'm just going to do these guys for now. And you end up with -3, 1, 2, -3, 1, 2, 3 up there, and then 3, 0, which is just out there, and that's R prime and Q prime, and hopefully you guys can see that. what you want to do then is take a straight edge. So let's get a straight edge out here. All right. Take this straight edge and connect those points. So, I mean, to us, they look parallel. They definitely look parallel. Let me bring it up for you guys a little bit. They aren't the same line. If you can focus. Right, you can tell that they are different lines, but they do look parallel. So what's the reason for them being parallel? Well, dilations preserve slope. Okay, dilations preserve slope. And when slope is preserved, right, when things have the same slope, they're parallel, right? So same slope means lines are parallel, okay? So dilations preserve slope, same slope means lines are parallel. So that's something we know, not too bad. Nothing super new. We're just doing those dilations and then figuring out that the slopes are the same. So let's take a look at the next one. So dilating a line. So a line, let's see, how's that doing? Okay, so a line whose equation is 3y plus 5x equals 12 is dilated with a center at the origin by a scale factor of 1/2. Okay, write an equation that of this line in slope-intercept form. So before we can do anything, we want to plot this so we can see what's happening. So to plot it, we need it in slope-intercept form. So we're going to change this to slope-intercept form. So we got 3y plus 5x equals 12. And if you remember how to do this, all you have to do is get the y by itself with some basic algebra. So we've got negative 5x plus 12. We're going to divide by 3 to both sides, and we're left with negative 5 over 3x plus 12. All right, well, now let's take a look. I'm sorry, plus 4. 12 divided by 3 is 4. Let's take a look. So we're going to go to our y-intercept just like we plot anything. 1, 2, 3, 4. And then we're going to go left, down 5 and right 3. 1, 2, 3, 4, 5, right? And right 1, 2, 3 there. The lines are a little bit not great. And then down again, 1, 2, 3, 4, 5, and right 1, 2, 3. And you'd get your straight edge out again, which I just put away, I don't know why. And we're going to make that line. Okay. So from here it's fairly simple, right? Because we have these points. All we have to do is multiply it by the scale factor. So the easiest one for us to do is actually take this point and just see where it goes. Right? So this point is 0, 4. And that's our y-intercept. So let's multiply that y-intercept by the 1/2. Okay, we see 0 times 1/2 gives us 0, and 4 times 1/2 gives us 2. Okay, well, that's 0, 2 right there. All right, this next one was 1, 2, 3, and down 1, it looks like. So that one's going to be tough for us to do, but we already know from the last problem, right, we said dilations preserve slope. So if dilations preserve slope and we already have a y-intercept, we've got an m, right? We know our slope's the same. It's negative 5 over 3. And now we have a b. We have a y-intercept. We just got it. It's 2, right? We did that by changing this y-intercept and making it the one dilated by 2. Okay, well, we can write an equation. It's y equals negative 5 over 3 x plus 2. And this is our dilated line, our d1/2. Okay? So all you have to do when they're asking you to dilate a line based on the origin or even a point off the line, all you got to do is multiply the y-intercept by this scale factor. So the next question asks you to do exactly that. It says explain why dilating the line y equals 3x by a scale factor of 2 about the origin would not change its equation. Well, we just said you got to multiply the y-intercept, and in this equation, the y-intercept is 0, right? Because there's no y-intercept there. So if you multiply this by 2, you just get 0, and your equation would be 3x again. So the reason why it doesn't change the equation is because there's no y-intercept. It would be the same equation, right? It would be the same equation. So fairly simple question there. All right. Then we're going to go on to 2 more, and then you guys are going to have an assessment to do as your classwork. This line, y equals 2x minus 4, is dilated by a scale factor of 3/2 and centered at the origin. Which equation represents the line after dilation? Guys, let's use our brains here, right? So they said it's a dilation. We know dilation preserves slope. So it's gotta have the same slope, right? They have to be parallel. So right away we can cross out 3 and 4. All right, then all we gotta do is multiply our dilation factor, right? Our scale factor by our y-intercept, which is -4 times 3/2, right? And we end up with 12/2, which gives us -6. So our y-intercept is -6, leaving our answer to be 2. Okay, this one I actually also want you to submit. It's a tougher question, but I'm going to tell you how to do it, right? So line segment AB, right, whose endpoints are this and this, right, is dilated 1/2 at the center, centered at the origin. It wants to know what's A prime, B prime. So, I'm sorry, it wants to know what is AB. So it's telling you A prime, B prime, right, had these endpoints. And it wants to know, okay, well, we dilated it by 1/2. What was AB? What are the endpoints of A and what are the endpoints of B? While this might seem kind of difficult, it's not. You know a formula about how to get length. What formula is that? Well, it's distance formula. If you don't remember it, look it up. It's also definitely in your notes. So all you're going to do is you're going to use the distance formula to figure out how long this is and dilate it by 1/2, which is literally just dividing by 2, and it's going to give you the length. It doesn't even want these points. You don't need these points. You just need the length. So you're going to do that for homework, and you're also going to do this assessment. I'm sorry, not for homework, for classwork. And you're also going to do this assessment for classwork. Okay, and it will be graded as your classwork. And don't forget to submit the notes for your attendance grade. All right, thanks for tuning in.